lines are in standard format, AX plus BY equals C. The A and B values are the same for each family, each member of the family, and the C values will change. When they're in this format, the easiest way to graph them is by locating their X and Y intercepts. If we let X equal 0, then our equation becomes 4 times 0 is 0, plus Y equals 4, so Y equals 4, and the point 0, 4 will be a point on our graph. If we let Y equal 0, then we get 4x equals 4, which will give us x equals 1, and 1, 0 will be another point on this line. So if we locate those 2 points, 0, 4, and 1, 0, join those 2 points with a straight line, to line up here. Not quite straight. Let me adjust that. There we go. And there. So it's going through the point 0, 4 and the point 1, 0. That's the first line in our family of isolines. And we'll go back and pen here again. Take our second equation, 4x plus y equals 8. Let's maybe do this in a different color. Make it a little easier to follow what we're doing here. If x is 0, substitute into this equation, we get y equal 8. And our second point, our first point on our second line is the point 0, 8. And then if we let y equals 0, we get 4x plus 0 equals 8. So 4x equals 8. Dividing by 4 gives us x equal 2. And 2, 0 is the second point on the second line. So let's graph the second line. And let's make this one red so we can tell things apart. So 0, 8, 1, 2, 3, 4, 5, 6, 7, 8 would be here. And 2, 0 would be here. And if we join those with a straight line, that looks straight. Adjust it just a little bit there. There we go. We can see the second line is parallel to the first line. And now let's go to our third equation here. 4x plus y equals 10. And again, we'll find the x and y intercepts. If we let x equals 0, this will give us the y-intercept. I know that always sounds backwards, doesn't it? 4 times 0 again is 0, so we simply our equation simply becomes y equals 10. So 0, 10 will be a point on the third line. Letting y equals 0 results in 4x equals 10, dividing by 4, 10 fourths, 5 halves. So 5 halves are 2.5. Let's call it 2.5 is x when y is 0. And we'll locate those 2 points on our line. Make this one green to match. So 10, 0 would be about there. And 2.5, 0 would be about there. So joining those up with a line. Again, you can see we get a series of parallel lines with the isolines. So that'll happen whenever we're working with a set of family of equations that are in the format ax plus by equals c, where a and b stay the same and the c varies. Okay, so the second topic I wanted to cover in this video are systems of equations. These will require a little bit more work than graphing those isolines. The isolines are pretty easy. So I've got a system of equations, and this system has actually 4 different equations in its, or inequalities in the system. X plus 2y is greater than or equal to 4. 2x subtract 3y is less than or equal to -6. then x is greater than or equal to 0 and y is greater than or equal to 0. I combine the two of those together using a little shorthand. So we're going to graph these 4 inequalities, and we're going to look for the overlapping area that satisfies all of the different inequalities. So to start off, get a little more room here. What I want to do is to graph the equation that parallels this inequality. So I'm going to actually graph here is the equation x plus 2y equals 4. So I'm ignoring the greater than for the moment. And I'm going to graph these the way I was graphing the isolines, locating the x and y intercepts, just because that's the quickest way to do it. So if x is 0, that would leave me with 2y equals 4. If 2y equals 4, y equals 2. And then if I let y equals 0, that would wipe out the 2y, and I'd be simply left with x equals 4. So I've got my x and y intercept here, and I can locate those 2 points on the graph. So let's see, 0, 2, and 4, 0. And let me fine-tune that a little bit. So I'm going to the point 0, 2, and going to the point 4, 0. Just a little bit there. Okay. And now I want to check a test point. So going back to my inequality here, now I'm looking at the inequality rather than the equation. And I want to pick a nice point that's on one side or the other of the line. The easiest point to work with is 0, 0. So as long as my line's not going through the origin here, I like to pick 0, 0 as my test point, because there's no number simpler to work with than 0 when it comes to substituting into an inequality. So if I'm going to test the point 0, 0, I'm going to plug it into the inequality. 0 for x, 0 for y. Is that greater than or equal to 4? True or false? Is 0 greater than or equal to 4? No. I think we can all agree on that. So the point, my test point 0, 0 was over here on this side of the line. It did not make the inequality true. That tells me I don't want this side of the line. Instead, I want this side of the line. On this side of the line are points that will make the inequality true. Let's pick a random point out here, say 5, 5. If I plug 5, 5 into the inequality, I'll get 5. Plus 2 times 5 is 10, so 5 plus 10 is 15. Is 15 greater than or equal to 4? Yes, it is. So if one point works on one side of the line, all points on that side of the line will work. If one point on the other side of the line does not work, then none of the points on that side of the line will work. And by work, I mean make the inequality true or make the inequality false. Okay, let's go to the second equation here in our inequality. So again, I'm going to find my x and y intercepts here. So if x is 0, that leaves me with negative 3y equals negative 6. So that would be 2. And then if y is 0, that'd leave me with 2x equals negative 6. So x would be negative 3. So I've got 2 points again. I'm going to graph those 2 points. So I'm going to go through the point 0, 2 again, but this time I'll be going through the point negative 3, 0. My line there, and then adjust a little bit. Okay, so I'm going through the point negative 3, 0 here, and the point 0, 2 here. Okay, now to test. Again, 0, 0 is just a nice point. Don't have to use the point 0, 0. I just find it easy. So if I plug 0, 0 into the inequality, I get 2 times 0. Subtract 3 times 0, which is 0. Is that less than or equal to negative 6? 0 is not less than negative 6. 0 is greater than negative 6, so this is also false. So again, I want to shade the side of the line. It does not include the test point. What I'm looking for here are overlapping regions. So you can see this area up here satisfies both of the inequalities that we've looked at so far. Now we've got two more inequalities. I've written them again in kind of a shorthand combined notation. X is greater than or equal to 0, y is greater than or equal to 0. X greater than or equal to 0, I'll first graph the line x equals 0. X equals 0, again, this is another one of those things that always sounds backwards until you think it out. X equals 0 is actually the y-axis, because every point on the y-axis, the x-coordinate is 0. So x greater than or equal to 0 is going to be this side of the y-axis, because here are where all the positive x-coordinates are. Y greater than or equal to 0, y equals 0 is the x-axis, and y is greater than or equal to 0 above the x-axis, because that's where the positive y-coordinates are. So those two inequalities keep us in quadrant 1. Now if I look at what overlaps the red area, the green area, and the blue area, that is going to be, another color here, this unbordered triangular region here. So it's everything out here, out here, out here, out here. This one happens to be an unbounded solution region, but every single point that lies within this area makes all four of these inequalities true. If I pick a random point here, it would make this inequality true, it would make this inequality true, and the x and y coordinates would be greater than 0. So that's what we're looking for.